Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the lecture series Knapsack problem. So let's see what is Knapsack problem. So Knapsack problem is a problem which states that in a knapsack problem it states that given a set of items, also it holds weights and profit values, one must determine the subset of the items to be added in a knapsack such that the total weight of the item must not exceed the limit of the knapsack and its total profit value also should be a maximum value. It is one of the most popular problem that takes greedy approach to be solved. It is called as the fractional knapsack problem. To explain the fractional knapsack problem, let us make the problem a little easier one. Consider a test with 12 questions, 10 marks each, out of which 10 marks each, out of which 10 should be attempted to get the maximum mark of 100. The test taker now must calculate the highest profitable question that one he is confident of to achieve the maximum mark. However, he cannot attempt all the 12 questions since there will not be any extra marks awarded for those unattempted answers. This is the most basic real world application of knapsack problem. So let's see the definition. In a knapsack problem or rucksacks problem, we are given a set of n items where each item is specified by a size Si and a value Vi. We are also given a size bound S, the size of a knapsack. Let us consider there are 3 items 1, 2, 3 and with the sizes of 1, 3 and 5 with the value of 8, 6 and 5. So let's see what is the knapsack problem. So the famous knapsack problem is a thief breaks down into the museum. The fabulous paintings, sculptures and jewels are everywhere around in the museum. The thief has a very good eye power for the value of these objects and knows that each will fetch hundreds or thousands of dollars on the clandestine art collectors market. But the thief has only brought a single knapsack to the scene of the robbery and can take away only what he can carry. What item should the thief takes to maximize the haul? This is the knapsack problem. So let us see the knapsack problem in a very shorter way. So a thief consider a thief taking W pounds of wood, capital W pounds of wood. The loot is in the form of n items, each with weight Wi and value Vi. Any amount of an item can be put in the knapsack as long as the weight limit W is not exceeded. So there are 2 types of knapsack problem. I hope you all understand what is knapsack problem. So there are 2 types. One is using dynamic programming solution, the other one is greedy approach solution. Dynamic programming solution solves dynamic programming solution is used to solve 0/1 knapsack solution and the greedy approach solution is used for fractional knapsack problem. So these are the 2 types. So what is 0/1 knapsack problem? So given a knapsack with maximum capacity W and a set S consisting of n items, each item I has some weight Wi and benefit value Bi. The problem is how to pack the knapsack to achieve maximum total weight or total value of packed items. So the solution is dynamic program. So the next problem in knapsack is fractional knapsack. So fractional knapsack problem, so here we are given n objects and the knapsack. Object I has a weight Wi and the knapsack has capacity W. If a fraction xi, that is 0 less than or equal to xi is less than or equal to 1, the object 1 is placed into the knapsack, then a profit P of xi is earned. The objective is to obtain the filling of the knapsack that maximizes the total profit earned. So this is how the fractional knapsack is. Maximize P of Pi xi subject to Wi xi is less than or equal to m and 0 less than or equal to xi less than or equal to 1, where all I belongs to 1 to n. So greedy algorithm gives the optimal solution for the fractional knapsack problem. So let's see the algorithm. So for I is equal to 1, the algorithm goes like this. For I is equal to 1 to n, do x of I is equal to 0, weight is equal to 0, assume, analyze weight is equal to 0, while weight is less than the capital W, do I is equal to the best remaining item. If weight plus W of I is less than W, then x of I is equal to 1, then increase weight to weight plus W of I, else x of I would be W minus weight by Wi. So weight is equal to W. So this is how the fractional knapsack greedy algorithm works. So when we do analyze this knapsack greedy algorithm, the time complexity will be theta of n log n. So if the items are already shortened into decreasing order of Vi bar Wi, then the while loop takes a time that is in order of n. Therefore, the total time including the short is in order of n log n. If we keep the items, then for the shorting it is n log n. If we keep the items in heap with largest Vi bar Wi at the root, then creating the heap takes order of n time. While loop now takes order of n long time, since heap property must be restored after the removal of root. So let's see the algorithm in a very short manner. Consider all the items with their weights and profits mentioned respectively. Calculate Pi by Wi or Vi by Wi of all the items and sort the items in descending order based on Pi bar Wi values or Vi bar Wi values without exceeding the limit. Add the items into the knapsack. If the knapsack can still store some more weight, but the weights of other items exceed the limit, the fractional part of the next time can be added, hence giving it the name fractional knapsack algorithm. So this is how the knapsack